This is a continuation of factoring methods. This will be more about special types of products. So let's begin using the flowchart again. We tried to look for greatest common factor to start off with. So 40 and 25 have a common factor of 5, but that 5 will not divide into 16. So there isn't a greatest common factor to pull out. Then we know it's a trinomial, so we check for the variable pattern. So the first term should have even powers. So first term does have even powers. The last term should have no powers or also even powers. Doesn't have any powers, or there's no variables. And then the middle term should have half of the powers that we've seen before. And so m has power 1, which is half of that power 2 here. Same thing with b. So it does work. So we can say, yes, it does. And this one turns out to be a perfect square trinomial. Let me show you why. So I'm going to show you two ways to do this. I'll do the crisscross method, which I prefer, but there's also the formula that we could use. So crisscross, record the question, and instead of listing all the combinations for 16, remember how I said in previous videos that you want to try a combination that's close together. So 4 is as close as we can get. 4 times 4 is 16. There's also 2 and 8 and 1 and 16, but I'm not going to record them because I might not even need them. Then we have 25. The last term is positive. So I always look at the last term to decide what signs I need to use in my factors. I prefer not to touch my first term with the signs there because I want the first term in every factor to be always positive. So 25 is a positive number. So we can have a combination of two positives that make that, or two negatives. However, this middle term has a negative, so two positives is out the door. We can't have that. Okay, so 25, we can have 1 with 5 or 1 with 25 multiplied to 25, or 5 times 5 is 25. I'm going to start with the combination that's closest together again. Because we already said we need two negatives, we can place them right away. Then we're going to crisscross and multiply. Don't forget about the variables. I forgot to mention that. We always want to split up the variables in an even fashion. Because when you do the crisscross, you have to get this mb out. So if you had m and b squared here and without the variable there, then you would not have like terms when you crisscross. All right, so let's do this crisscross to multiply. So 4 with negative 5, that's negative 20 mbs. And another negative 20 this way because it's symmetrical. So negative 20 plus negative 20 is negative 40 that we want. And so we can record top with the top together as one factor, bottom with the bottom as a second factor. And because they're identical, you can just say that bracket with a square. Now, why is this trinomial called the perfect square trinomial? I'm going to show you a visual that is often used with these. So it's actually going to be a perfect square instead of a rectangle when we factor this. So if we put the first term as the top corner, inside this bigger square is another smaller square. And this last one we have in this bottom corner, another square 25. So because it's a perfect square number, we can think of 16m squared b squared as having sides 4mb this way and 4mb that way. So this side and that side is identical. And when you multiply length times width, you would have this area on the inside. And then this 25 could be negative 5 with negative 5. It gives us this positive 25. And so the other parts of the chart could be filled in because this is length negative 5 and then this is width 4mb. If you multiply them together, you'll have negative 20 MB there. This is just an analogy. Length can't really be negative. This is just for the sake of showing you how it ties to represent as if it's an area. And same thing with this one. You could do length times width and get this middle term. And so these two together do add to this middle one. So you can consider this expanded version as area. And then if you get it to be factored, you're getting the length and the width of this perfect square. So this is the length and this width happens to be the same. And so we call it a perfect square because we have a factor with a square there. Let me show you also how to use the formula. So the formula is provided here. Here's the question. So what you want to do is identify the first and the last term are perfect squares. So what is being squared in the first term? 4mb, when you multiply it by itself, you get this first term. And what is multiplied by itself to get 25? Well, it's 5. Then you can think of this inner bracket as just the a, and inside this little bracket is the b. So this is a squared total, and this is b squared total. Then we want to check, does this middle term, is it of the form 2ab? Forget about plus minus, we'll talk about that later. So finding out our a and b, we just need to check whether it multiplies to this. So 2a is 4mb, so place it here, b is 5. If you multiply those together, you do get this middle term, 40mb. So it is a perfect square, so you can follow the formula. In our question, we have a negative. So that means in the formula that you follow is going to be this negative sign here, and that means our factor is going to have a negative as well. And so you just record it, and you get the same result. Let's try another question. Is there a greatest common factor to pull out here? There isn't. So we move on. This is now a binomial. So for binomial, we're going to ask ourselves, do we have perfect cubes, perfect squares, or something else entirely that we cannot do? And I would say that this is perfect squares, and specifically a difference of squares. So you could, of course, use this formula, or I'm going to show you how crisscross still works here. That's why it's my favorite method. So here is the question, crisscross. So in order to do crisscross, we need to create a trinomial. So you could pretend there is a zero term in the middle of these two. So you could think of it as 0y x squared, or just 0, who cares what's the variables on the inside. And then you proceed by listing off factors of 36. And there's lots of factors of 36, but let's start off with the combination that's closest together. So 6 and 6, and y with y, because we need y squared. With 25, we can have 5 times 5 and x squared. So these will give us this. However, we need a negative 25. So that means we need to have one negative. So it doesn't matter where you place it, let's place it somewhere. Then we want to check if this combination will give us this middle 0 term. Well, these two multiplied together will give us positive 30 x squared y. These two multiplied together will be negative 30 x squared y. When you add positive 30 with negative 30, you would get the 0, which does work out. So you don't even have to try other combinations. This is it. You can record them. Looking at this, there's a pattern. There's identical terms here as the second factor, except the sign is the different ones. So for difference of squares, it always follows this pattern, and this is where the formula comes from. So using the formula, we need to identify what is the a as a square and what is the b with a square. So the first term is 6y all squared, gives us 36y squared. The second term is 5x squared all squared, gives us this original. So then you have to say that a would be just the 6y, b would be the 5x squared, and then you have to check that you have a difference. So if it's not a difference, it doesn't work. We do have a difference. Then, quick note, this is why this type is called a difference of squares, because we have a subtraction between two perfect squares. And so you set up the formula. Here we have one binomial with a plus and one binomial with a minus. And then you use your a's and b's to fill it in. So 6y goes in the first position of both factors, and 5x squared goes into the second. And it's the same thing as we had before. The order doesn't really matter of the factors. So here we have a plus sign, here we have a minus first, but multiplication order doesn't matter. Just think about 2 times 3 is 6 versus 3 times 2 is also 6. So you can change the order of the brackets or factors, and it should be fine. Then we're going to record this answer up here to see if we can do this further. So each factor is a binomial. So we're going to go in this branch of the flowchart. Then we need to check, can we identify this as perfect squares or perfect cubes? Well, if you look at the variable y, it doesn't have a power on it that's 2 or a 3, so it's not perfect square or perfect cubes. And so this you cannot factor further, and same thing with the other bracket. So in summary, before we do the perfect cubes video, I'm going to discuss with you the reasons why I like the crisscross method. So all of these methods right here, instead of remembering or memorizing ways to do it, for this question you do this, for that question you do that. All of these could be taken care of by the method that I call the crisscross method. Then on top of that, you'll just have to remember to do GCF factoring. You still would have to know how to do grouping factoring, and of course this is still to come. It is also important to know how to decide that things do not factor. So let's go on to do a couple more. So let's look at this question. There is nothing in common to pull out. It is a binomial. It looks like it's 10r times 10r is this first term, and 9s times 9s is this last term. So it looks like two perfect squares. But in the middle, it's not a minus, so it's a sum. So we cannot factor this using integers or real numbers. It actually is doable with imaginary numbers, but that's another conversation that we could have later. So for this question, you would just say not possible to factor. And on a test, you might have question, or at least one question, that I would ask you to factor when it actually is not possible. So your solution would be that there is no solution. What about this one? So there's nothing in common to factor. It is a trinomial. Does the variable pattern follow? Yes, it does. It's a simple trinomial, so you might say, oh, a simple trinomial, it must work. Let's take a look at this question. So you could do sum product, or I'm going to proceed with my crisscross method. So list factors of the first term. So 1x times 1x is x squared. List factors of 40. So 1 divides in, 2 divides in, 3 doesn't, skip. 4 divides in, 5 divides in, and then 6 doesn't, 7 doesn't, and then 8 is already on the list. Then this number is a negative, so all of these combinations here should have one negative. So I'm going to choose to put the negatives on the smaller numbers because when you crisscross and multiply this, we need to get a result that's positive 22, and it's not going to be possible to have the negatives on bigger numbers, and we'll have a negative middle term. So if we proceed here, we're going to have positive 40, subtract 1, well, that's 39, that's not 22. Then positive 20, subtract 2, so that's 18, that's not 22. Then we have 10, subtract 4, so that's 6, that's not 22. And then 1 with 8, so that's 8, and negative 5. When they add those, we get positive 3, that's not 22. So even if you were to put the negatives on the bottom, you'll see it doesn't work. If you were to reverse the order of the list, actually that's silly to do here because 1 and 1, if you reverse the order on the short list, it stays the same. So if you've exhausted all the combinations and nothing gives you this middle term, then this question you would say not possible to factor. It is very important for you to pay attention to the signs, because if you didn't, you might say, well, 2 plus 20 is 22, and then you'd say it factors. But remember that positive 2 and positive 20 will not multiply to a negative 40. So it can't just match one of the numbers, it has to match both of them. So watch out for that.